Hello everyone. In today's video, we will see what is digital image processing. So here the digital image processing, it is comprised of three words, that is digital, image and processing. First we'll see what is an image. The word image, it refers to the visual representation of something. That is, it can be a photo, drawing, scanned picture or any graphic scene on a screen or printed on a paper. So that is nothing but an image. So this was generally defining the image. Here, according to the definition, it may be defined as a two-dimensional function f of xy, where x and y, these will tell the position, that is the coordinates of the images, coordinates on the image, and f of x comma y, it gives the intensity, that is the brightness at that particular point. So an image, it is like a grid where each picture, where each point, it has some brightness value. Okay, so that is nothing but an image. So you can define image as a two-dimensional function f of x comma y, where x and y are spatial, that is the plane coordinates. Next comes the intensity or the gray level. So here intensity or gray level, it means how bright or dark a point in the image is. That is, it defines the amplitude of the function f at any pair of coordinates x comma y. Suppose for example, if f of 10 comma 20 is 150, it means that the pixel at 10 comma 20, it has brightness 150. Okay, so that is nothing but the intensity or the gray level. Next comes the digital image. So a digital image is one where x and y coordinates are limited and countable. That is, these are finite and discrete quantities. That is, the intensity values are so finite and discrete here. For example, it will be in between 0 to 255. In simple words, if you see a digital image, it is made up of a small blocks, that is called as the pixels, which are arranged in rows and columns, and each block, it will have a brightness value. Next comes the digital image processing. So digital image processing, here it refers to processing images by means of a digital computer. That is, we'll use a digital computer in order to process or enhance the images. That is, we'll perform some task like removing the noise, improving the sharpness, then detecting the edges, recognizing the faces, and so on. Next comes the pixels. So here, pixel, it is the smallest unit of a digital image. And here the pixel, it is nothing but a location, that is its position in the image, a value, that is the intensity or brightness or the colors. So in general, you can define the pixel as nothing but the finite elements of the image. Okay, that is a finite number of elements in an image. Or you can say it as a digital image is composed of a finite number of elements, each of which has a particular location and value. Okay, location is nothing but its position in the range in the image, and a value is its intensity or brightness or color. So here other names of pixels are picture elements, image elements, or pels. Suppose if you want to know, like, just for example, you have a checkerboard here. If you have a checkerboard, you will be having small squares in the checkerboard. So each square, you can consider it as one pixel. Okay, and the color of each square will define the pixel intensity, and all the squares together, these will form the digital image. Next we have that is vision. Among all human senses, the vision, that is seeing, is the most powerful and advanced. Okay, that is the most powerful and advanced senses where which a human has. So the images will help the humans to understand, recognize, and interpret the world. For example, when we see objects, we immediately understand their shape, color, size, and distance. but human visual vision, it is limited. Okay, so here humans can only see light within a small portion of the electromagnetic spectrum, that is from the gamma to the radio waves, and the human eyes sees only the visible light. Okay, that is in between this range. Meaning to say is that there are many forms of energy like X-rays, ultraviolet, infrared, etc. that exist, but we cannot see them all with our eyes. So because of that, we use the imaging machines in order to see the things beyond the human vision. And these machines, these will generate the images from the sources humans cannot see directly. For example, you have ultrasound, that is, it is used in medical imaging in order to see the organs inside the body. Then you have electron microscopy, where it is used to see extremely small objects like cells or viruses. Then you have computer generated images, that is, you will be having simulated images which are created using the computers like 3D models, animations, etc. Next is types of computerized processes in the digital image processing. You have three types of computerized processes. First is the low level processes, then mid level processes, and high level processes. Or you can say it as low level process, mid level process, and high level process. So here low level process, it is like it will be basic, its basic operations are noise removal, image sharpening, etc. Then you have mid-level processing, where you have like you will be having the extraction or analysis of features from the image. And for high-level processing, you will be understanding the meaning of an image, like recognizing the objects. Now we will see each of these in detail here. First is the low level processing. So low level processing, here it refers to the basic operations performed directly on the image in order to improve its quality. It does not try to understand what the image represents. It only enhances the image. Okay. The job of the low level processing is just to enhance the image. It will not try to understand what the image represents. So here these are the first steps which are done before the further analysis, low level processing. And the main goal is to reduce the noise, that is remove unwanted distortion or graininess. Then you have contrast enhancement, that is make the bright and dark areas more distinguishable. Then you have image sharpening, making the edges and the details clearer. So here you can see this is the low level processing system, where you will give the input as the image and the output will be an image. Okay, so here no interpretation is done. The result you get back is also an improved image. You will give an image, you will get an improved image here. Okay, so like suppose for example you are giving an image which is blurry, noisy and dull, and after the low level processing you will get a clearer and sharper image. Okay, so here the low level processing is like cleaning and enhancing the image, and it is without trying to understanding what is inside the image, just it will clean and enhance the image. Next you have the mid-level processing. So mid-level processing, it focuses on extracting the useful information from an image. Unlike the low-level processing, it only which only improves the image quality, where here the mid-level processing, it tries to understand the image in parts. So here the key functions of the mid-level processing are segmentation, that is dividing an image into regions or the objects. For example, you have separating a person from the background in a photo. Then you have feature extraction or the description, that is describing the objects in a simpler form so that a computer can recognize them. For example, you have identifying the edges, then you have to identify the corners, shapes and boundaries. Next is classification or recognition, that is labeling or identifying the objects in the image. For example, recognizing that an object is a car, a tree or a face, like that. Okay, so here usually the input for the mid-level processing are images, but the outputs are nothing but the attributes are the information which are extracted from those images. So instead of giving suppose here you will be giving an image to the mid-level processing, you will get the attributes. Okay, so suppose you have a picture of a cat. Now you want to do the segmentation. So what happens here is the cat will be separated from the background and the output will be cat region. Okay, that is, here you will give a input as cat. When segmentation is done, the cat is separated from the background and you will get the attribute as cat region. Feature selection, like here when you give an image, it will extract the shape, edges, texture, and here attributes will be the feature values, like that. Okay, next regarding the recognition, here it will identify the system, identify the object, and it will label that as cat, because we will be giving the image of the cat, so it will label that as cat. That will be the attribute, that is, the label will be the attribute. So mid-level processing, it will understand the image parts, that is, it will understand the parts of an image by cutting it into meaningful regions, then extracting features from those regions, and identifying or classifying the objects. So here it starts with an image, but it will end with the information, that is nothing but the attributes. Next is high level processing. So here high level processing, it is the final stage in the digital image processing, where it focuses on understanding and interpreting the information which is extracted from the image, not just detecting the objects. Okay, so it will understand and it will interpret the image. That is, once the mid-level processing has identified the objects and their features, this high level processing, it will try to understand what those objects mean. And here high level processing, it is understanding along with the interpretation, not just the detection, and it will make the sense of the scene. That is, it will that is nothing but reasoning about what is happening, then drawing conclusions or making the decisions and predicting the outcomes. So this is similar to how the human brain understands the images. For example, suppose you have a traffic image. In low level processing, what happens is it will identify the noise induced, then it will sharpen the edges. There you will get the clearer image. Then in the mid level processing, there you will get the cars, roads, then the pedestrians, these all are detected. That is, object is detected there. Okay, or you will get the features, then there will be a labeling done in the mid-level processing, whereas in high-level processing, the system will conclude that whether a person is crossing the road, okay, and whether the car has stopped. That is, it will make decision and it will give meaning to that image. So higher level processing, it is nothing but the interpretation along with the reasoning. Okay, so here you can have some examples for higher level processing as self-driving cars deciding when to stop or turn, then security systems identifying the suspicious behavior, or you will be having the medical imaging recognizing the disease pattern and the suggesting of the diagnosis. These all are some examples of high level processing. So this was about the topic, what is digital image processing. I hope you have understood. Thank you.